Hi, and welcome to the tutorial on how to create a game in Python. This tutorial is beginner friendly and will lead you step by step to a result that will look like this. As you can see, it's a side shooter game where you can control your player, shoot some enemies and getting some perks. Please note that this is one of the simplest games you can make with Python, and you have to have already the knowledge of basic constructs like variable, for loops, whiles and if, then else. We will use Pygame and we will pay attention to some object-oriented programming principles. The code and the assets are available on GitHub and you can find the link in the description below. Our roadmap will include the design of the classes of the game, we will introduce the game loop, and then we will start to draw some sprites on the screen. Moreover, we will handle the input of the users and the events. We'll control autonomously the entities and also by keyboard. We will detect the collisions, refine at the end the game mechanics, and as extra introduce like health, score, stats and music. Let's have a look at the initial setup. If you have Python already installed and you know how to install packages like Pygame, you can skip already to the next chapter. For the requirements, I will suggest you to go to anaconda.com and download the software. This will ease you to use Python and Pygame. To verify if you have Python installed, you can type python ---- version. Meanwhile, if you installed Conda, you can check and create an environment with Conda, create -n, name of the environment will be Pygame, and then we install Python. After collecting some data, it will prompt you to say yes to install the packages. Now we have our environment with Python created. We can activate it with Conda, activate, and the name we gave, so in this case Pygame. Now we can install the packages required since it's a clean environment. We can install Pygame with pip, install, and Pygame. Remember to activate the environment every time you open a console if you want to use Pygame. Perfect. Now we can type Python to enter in the Python command line and import Pygame. Here we go. Now we are ready to go. Let's now start with the design of our code. It's a crucial step to make our life easier later. You can just follow the design to have an idea on how we will build the code later. We want to think about all the objects that are in the game and we can model. We need for sure a game class that will hold all the instances and will run the game. Then, of course, we have the player, the enemies. Then, since the game is based on COVID and on cells, we can think that both of these entities are the same as cell. So we can create a top class entity and we call it cell. Now, for the purpose of being a simple tutorial, we don't make interface of our abstract classes. We will just use classes to model our game. So now, player and enemy share some properties in common, and these properties will be part of the class cell. The game will hold some cells in it. We can model other entities like PowerUp and bullets that are always of type cell. Now, if we want the enemies to be different, we can also model some other classes. Let's call the enemy virus. Other enemies like COVID-19, Omicron, and Delta. Power-ups, let's call them booster. And it can be a mask or a vaccine. We can also specialize the bullet in subclasses like normal bullet and rocket. Now, all these classes will have something in common. They will have in the screen some position, image, some health. Also, we can guess that all the bullets will have in common the damage they make to other players. So this damage goes into bullet and not into the other entities. Booster on the other side will have the health increase, and let's give the player the score. We give the score to the player and not to the cell, because in this way many players will have one for each one. Let's call it also white blood cell. Also the viruses will have some damage. In this scenario, we could have created a class that captures the damage of virus and bullet, but for now, for the simplicity, we will leave it like this. Of course, the game will hold all the entities listed below, and it will decide with some methods the logic behind it. So it will have run, it will have close, of course, and it will have reset. Now, for the sake of simplicity, we will ignore the methods of the classes. So, after simplifying a little, this will be the final design of our game. Of course, it can be changed and the game can be personalized with other subjects. Inside the folder where we want to create the game, first we will create a new folder for the assets and the images. I use already my own folder with the assets that you can find on the code. You can download it with GitHub code and download zip. Otherwise, you can create your own assets and your own images and put them here. Next, we will create finally our first piece of code. We create a new text file, we call it game.txt, and once we open it, we can write our first code. Let's try to write simply just a print. We can import system variable, operating system, and random that we will use later. Then we will import pygame, and secondly, once we have all the imports ready, we will create an enter point for the code. To tell the computer to start execute the code in a certain point, we write this line. Now the computer will start to execute the code from this line. First thing we do, a tab, and then we write print. It works. Now we save the file. Of course, this is a text file, and we have to rename it .py to tell the computer that it's a Python code to execute. Let's now open the Anaconda prompt and navigate to the folder where we created our game. Okay, once we are inside the folder, in this case d/my folder, we can see there is game.py using the command ls to list all the content of this folder. We can execute game.py only once we have activated our environment. So we can activate conda activate pygame, and we will see that between parentheses pygame is activated as an environment. Now we can execute the game using Python and game.py. If everything works well, we can see hello from Pygame community and our text, it works. If you're not using Anaconda and you're installing Pygame straight in the system, you should reach the same point. Moreover, if you're executing with Visual Studio and you are pressing the play button, you should see the same, it works. Now let's edit game.py to create our game seriously. You can edit it with any editor you like. Initially, let's create and define the class game. The class game will contain the main game and it has, for now, two methods. The class is like an stencil that allows you to create objects in the same way. The first method that we create is the method that will be executed when the class is created. Of course, with Python, be careful with the indentation and the tabs between the lines. The second method that we create is the method that will be called when the game is running. To create an object game, we will write this line, and now we will have a game object. And then with game.run, we will call this method to start the game. Remember to save it, and when you execute, if you have an error like indentation error, it might be because there is a point in the code where you don't have all the indentation with spaces or with tabs. So you just have to be consistent with either spaces, either tabs. I will use spaces in this case. Remember to save it, and when you execute, you can see that the game should be running. Okay. For now, we just wrote text on a console, but our game won't be text-based, will be graphical-based, so it's time to create some windows. We can create our graphical user interface, so our window that we will call screen, with self.screen equals pygame.display set mode, and we give the resolution that we want. After that, we can create a title for this window that will appear on the top. In this case, we set caption side shooter game. Now we create the game loop. So we create a while that runs our code inside forever. Inside the while, we will write self.clock.tick and 60 for the FPS we want our game to run on. For this reason, we have also to define clock in the initial part with clock pygame time.clock. This will help us define the frame per second of our game. Inside the game loop, then, we will fill the screen with a single color, in this case 000 equals black. And lastly, we will write pygame.display.flip to create the screen and render it visible. Now when we save and we go to execute our game to see the window, we can see that the window appears, and finally we have a graphical user interface. Is it all black though? And when we press something, well, it gets stuck. This is not the best game experience I signed for, you will say, but it's normal. We started a loop and we didn't put any condition to quit it. So we can open the terminal where the game is running, press Ctrl C and we'll kill the game. So we will create a new method and we will write it close that will close the game when we want. We will use pygame.quit to softly quit pygame and then also system.exit. This will close the window. Of course, this method is part of the class game that we created. We will call it when the event will be triggered when we press a key on the keyboard. In this case, we will check all the events in the pygame event.get. There will be a queue of events here that we can get. So, for every event that the system has, we will see if the event is a quit or if it's a key down, a keyboard pressed, and the key is the escape key. So in this case, if the key is pressed down and is escape key, we will call the method close. Lastly, we have to import the keyboard keys that we are using. We will, next to import, write from pygame.locals, we will import the key up, down, left, right that we will use later, escape and quit in this way. Now when we save and we will execute the game, the window will appear. But this time we will be able to get out of the window pressing the button ESC. As we can see, we closed the game successfully. Okay, it's now time to add some fun, meaning it's time to add the main player to the screen. Recreate a new text document as before and we call it cell.py because will contain the class of the cell. Editing this .cell file, we will add as before the import of pygame and the import of the operating system that we need. Moreover, we will add the class cell as we want with in parentheses pygame.sprite.sprite. This means that we'll inherit some methods from a class that pygame gives us. We create the init method when the cell is created will be called, and we put in parentheses self, that has to be written, image because the cell will have an image, position X, position Y, we will give these things when we create a cell, the name, that in default name is just cell, health, because every cell will have also health, height and width for the image, because we will use it to draw it on the screen, the speed, X and Y, so we know what is the speed of the cell in whichever direction. After the init method, we have to call super and init, because we have this sprite as a parent and our class cell is inheriting from another class, so this will call the init of the other class. This has to be called every time there is a class here in between the parentheses. Now we start to get these parameters here and save it inside our class. Firstly, we get the image and we save it as a variable image that we will use later. Then position X and position Y. Moreover, we will use the name, and so we will save it in its own parameter, in its own variable. Moreover, we will get health and we will save it in a variable, and also we will save it as max health to remember what is the max health of the cell. We will use height and width, so we will save it when they pass us as a parameter, or if it's not passed as a parameter, they will have by default these values here. We will save the speed X and Y in its own variables, and moreover we will save the initial position for a reference X and Y. Remember that this class, as a stencil, will be creating objects for all the entities of the game, player, viruses, PowerUps, and also other things. And it's actually the first step of the pyramid that we defined when we did the design. It's a little bit hard, but will help tremendously when we will recycle its code to create other entities. Now that we saved all the variables passed at the creation, we can also create the surface of the image that we have. For this reason, we will use self-surface as the image, pygame.image.load, and we will use resourcePath. ResourcePath is a method that we will have to create, and we will use for also other parts of this game. So we will import it from resourcePath, import resourcePath, and we will create a new file. We will create a new file, resourcepath.py. In this file, as usual, we will import the system, the operating system, because we will use to load the image, and we will write a method that will be useful in other parts of the code so we can recycle it, which gives a full path given a relative path of any instance. We save this file, and so when we import this method up here, this method here will be working. For this reason, when we load inside the folder image, the image that we will get written here and we have saved here, at this point the image will be correctly loaded with the full path inside cell surface. Now last thing we have to do is create another method, draw, that will be called when we have to draw the cell on the screen. In this method we will write screen blit cell surface, that is this cell surface that we created before, and at the position X and at the position Y that we will have before in the cell. Now in the game file we will go to the init, so once the game will be created, will be executed once, and we'll start to create game elements. So now we can create our cell. We will create a cell, we'll call it player in this way, with an image as whitebloodcell.png inside the image folder, and the position X and Y will be 20 for 20. Of course we have to import the file we created, so from the file cell import the cell. Now this will be recognized and the player will be created. Now that we created a cell, we can draw it inside the main game loop after the drawing the background with self.player.draw and on the screen. When we save everything and we execute our game, we can finally see that the cell is appearing in the window. Now, if you have any problem, remember that my full code is available to see any difference. Moreover, I will make the code available in this state as checkpoint 1. Now, the most boring and complex part is gone. We learned how to create an object, in this case, using a stencil like a class. This is a stencil that will create an object. And when it's created, see what's happening inside the init, and then call a method that we can define, like run, later on. We learned how to recycle some code that we define in other files, and also we learned how to create in a different file a class that always acts as a stencil to create objects of type cell, with different methods that we can call. In this case, we call the method implicitly init when we create it and we create an object player, and we call the method draw when we ask the player to draw itself on a screen. The fun part is that we can recycle the code creating other objects. For example, we can create virus2, and if we have a virus2 image inside the folder images, we can say, okay, create a virus2 in the position 620 and 20. We don't have to forget also to ask the virus2 to draw itself for every frame inside the game loop. So we execute the code and we see that it's appearing next to the other cell. Now I will delete virus2 because it's just an example on how we can use the class cell as a stencil to create different objects in object-oriented programming. What we want now is to resize the player size. Of course, if we don't specify anything here in the creation of this cell, the size will be the default one, so 256. We want the player a little bit smaller, so we can say height equals, let's say 60. But also width. At this point, to save the important numbers in the code where we can find it, we can define some macros. Another important pair of numbers that is hidden in the code is the resolution of the screen. We want also to highlight it in a place where we want to see it better. So now, straight after the init part, when an object is created with this class as a reference, we can say, okay, let's create some macros, some variables that we can keep clear on site. So size, that will be this one, and also player size, that will be 60, and player speed, that will be 5. These will be clearly visible in the code being at the beginning of the class, and we will use it later. For example, here we can say self.size, the size of the screen. so we can use it also later if it's needed. Moreover, we will give the player height, width, as defined in player size, and also the speed, so they will be custom for the player. Inside the cell, after creating the surface, we will add scale to scale the surface to the desired size. Now, when we save the game and we execute it, we can see that the size of the player is as we want. All this effort just to create an image? Well, yes, but thanks to the object-oriented programming principles, we created solid foundations for later. Okay, let's now go to the fun part, movements and input of the users. Since we want to move the cells and every cell of the game has to be moved or can be moved, we want to create some function, firstly to get the position and set the position, and then to move it manually and one day in the future also autonomously. First thing we do is go to the cell file and create some new functions. The first function we can create is getPosition. GetPosition will give, if called to a cell, the position of the cell itself. And we will return indeed the position x and y. Another function we can make is setPosition, and this is the opposite, so it will set the position of the cell. So we get position x and y from the arguments passed, and we set it to the position x and y of the cell itself. Okay, let's now get to the movement of the cell. We will create some functions up, down, left, right to move the cell how we want it. First function will be up, and we set the position of the cell vertical position as the previous vertical position minus the speed. The speed is the amount of pixel it will move for every step. In this case, we define at the beginning in the cell the speed of itself. The second, it will be down, and it will be the opposite. The position vertical, y, will be the position before plus the speed. Same for left, will be position horizontal, x will be previous minus the speed, and right will be x plus the speed x. Move autonomously will be a function that will be defined later, so for now we'll leave it like this, not implemented. Now, inside the main game file, inside the game loop, before drawing and after the events, we can start to get the keyboard state with pygame.keyGetPressed, and if the keyboard state is pressed on the right, we can ask the player to move right. This will be executed for every frame. So on so far, if the pressed is left, the player will move left, and if the keyboard pressed is up, player will go up, and down, player will go down. Now, if we execute the game, we can see the player can move around depending on the keys we pressed. But wait a moment. In the cell code, we need to change when we ask the cell to go up. Well, if the position is less than 0, we need to keep the position 0. And the same if it goes left farther than the screen. If the position is less than 0 on the left, we'll keep 0. Let's remember that the origin is on the top left of the screen, and going right will increment the x and going down will increment the y. To prevent every cell to go too much down and too much right, it depends instead on the size of the window. So we create an if the position is greater than the window size subtracted the height of the cell, so we can still have the cell touching the bottom but not going with the tip too much down, we keep the position that one. On the right, if the position is greater than the window size minus the width of the cell image, well, we keep that as a position. We can see that the cell doesn't go away from the borders anymore. It's time to create some enemies that will move autonomously. Obviously, we could use the cell and copy and paste and create an enemy here. But the autonomous movement we will implement in the cell will affect also the player. So it's time to create a subversion of the cell, a specific version for the enemies. So let's create a new file and we will call it virus.python. So it's a code that can be interpreted as Python code. In this file, we will create a class that inherits from the cell we created before, so it will have the same code. And obviously, we will have to import the cell from the cell and import pygame. First, the constructor that will be called when we create the virus, and in this constructor we will add virus type as the virus name that we want to create. Moreover, we will call the previous constructor, that is the constructor of the cell, and we pass all the arguments here to the constructor of the cell. At the end we save the virus type internally at the virus and also the damage as a variable. So now we can finally define the move autonomously function. In this function we want the cell, for example the virus in this case, that it's a subclass of cell, the virus will move left, so it will start from the right part of the screen and move left, till obviously the position will be 0. At this point we can reset. For the reset function we will have to define in the cell file a function reset that will be able to reset all the cells at his initial health and at his initial position. In this case, as we inherit from the cell and we created a class virus and we created this subclass, we can create other subclasses for different types of virus as we define in the diagram in the design. So let's create a class like COVID-19 that is a type of virus. It will inherit from virus that is inheriting from cell. So COVID-19 will have all the methods of virus and all the methods of the cell class. So we create a function as before that when the object is created takes all the arguments that we want. We also give a name that we will use later as a virus type. So for this function we call the init, that will be the init of the superclass that it's virus, so it will be called like this, with virus type as COVID-19, and the name is COVID-19 indeed. All these arguments here will be passed indeed to the function that initialize the virus. So in this way we can create also other types of viruses like Omicron, for example, and we create the same function that initialize the virus and name is Omicron, and we can give a damage that is bigger, for example. And we also of course have a different images when we create Omicron, and Delta, another one with a different damage and a different image and a different virus type, so it will be easy then to create them. So now in the game code we can create properly inside the creation of the game in the init function the virus. We will create the COVID-19 virus since we have already the different types of viruses, and we'll give the image that we will put in the EMG folder. Moreover, we will import obviously the virus from the virus code. We will import everything, so we will have also the other types of viruses. Furthermore, we can say, okay, let's give the enemy size and the enemy speed inside the macros. So we will define some variables like size equal 30 and speed equal 3 that we will give for further reference to the enemy here. Now that we created inside the run, when the game is executed, we can move the enemy. The enemy will be called and move autonomously, will move it a few pixels on the left. We have to remember, of course, to draw it. After the player, we will draw also the enemy on the screen. Now we execute the game and we can see that we can move around, we cannot go beyond the borders, and the enemy will spawn and reach us. Since we want more than one enemy, we can copy and paste the line here, or we can create a for. Let's create a for, and we create a variable clearly visible up here in the macros with the enemy number. This will help us change it later. Since we want then to draw all the enemies one by one, we can create, to simplify the procedure, a group. Beyond the creating game elements, we create a group with all the elements of the game. This group will help us to save them and then to draw them all together. We add to the game elements the player, and also we add to the game elements all the enemy once we create them. Furthermore, we want to create a group only for the enemies that will help us to give them some properties later. We also add the enemies to that group. Now, instead of moving autonomously one by one, we can cycle and create for every element in the group, in the game, we can move autonomously the element. Finally, for the drawing part, instead of drawing all the elements and the entities one by one, we can just cycle through the elements of the game again and call them to draw it themselves on the screen. Let's now test it out. We can move around, okay. We cannot go beyond the borders, and here they are, all 5 enemies are spawning, and when they are reaching the end of the screen, they are spawning again back on the other side, being reset and starting again to move autonomously. The beauty of writing a reusable code is that now we can add more features easily and not write a lot of code anymore. So for example, in this case, we want to create another enemy, an Omicron. We can just create an Omicron, get a different image and maybe a different speed, and then we can add it to the group of the enemies and add it to the group of the elements. Or moreover, we can create another one like a delta, different image, and then different speed, and we can add it to the group of enemies and add it to the group of elements of the game. We don't have to worry about moving it because all the elements of the game will be called to move autonomously, and also about drawing it because all the elements of the game will be called to draw autonomously. Let's just add the size of the new enemies, Omicron and Delta, up here so they are easy to find. Now we are testing it again, and as you can see, there are different types of enemies appearing on the screen with different types of velocities. Similarly, let's create the booster file .python and let's edit it. Let's import the cell from the cell file because we will extend it and create a booster, so a power up that will be always a cell. Let's create the class booster that inherits from the cell all the properties, and of course when the init function will be called when we create a booster, so a power up, we also have to call the super init function of the cell. In this case, in the booster, we add booster type, for example, health increase and collision protection time, because the booster will have an health increase of the player and will protect it for a period of time. Moreover, we will create the variables, so when we create the booster, we will save the booster type inside a variable, another variable for the health increase, and another variable for the collision protection time. So inside the booster we will have the cell variables and these variables here. Let's go to implement the function move autonomously as we did before, and we can say okay, also the boosters will be spawned and will move to the left. The new position will be the previous position minus some degrees of pixels that will decide. Moreover, like if we go beyond the left border, we will reset the cell. Let's create some subclass as before, so we can personalize it even more. We create a mask, so has more protection time, then health increase, and will protect for a period of time the player. We create the init function, so we call with this init function the function of the booster. As we can see, it's extending booster, and we give as a default health increase 10, collision protection time 10. We give the name as mask and other default variables. We call as before the init of the cell, and we give all these arguments here to the init of the cell up here. Okay, let's create also the vaccine that will be another booster and will have more health than protection time. In this case, as before, we ask the vaccine class to be created with these arguments, and we have the default health increase at 90, for example, and this health increase will be passed at the init function of the booster here that will extend and ask the super init function of the cell to create a cell. Now we know the way, so we import from the booster file all the classes that we just created. Then we create some variables up here so it's easy to find for the size of the power up and the power up speed that will determine how fast it moves. Moreover, at the end of the creation of the game, we can see, okay, let's create some power ups. The group, first of all, so we create the group so we can add them for later. The mask, so we create a new mask and we give it an image, a position, initial position horizontal that will be a random between 6 times the screen and 8 times the screen, so it will eventually come a little bit later, and the position Y vertical that will be another random between 0 and the height of the screen. Moreover, we add the mask to the power group that we created and we add it to the all elements group, so then it will be drawn. Moreover, we create also the vaccine, so we have a different power up with a different image, also a different random position at the beginning between 4 and 5 times right of the screen, and eventually it comes inside the screen. We add it to the power up group, so it will be part of the power up group for later, and also to the elements group, so it will be drawn. We add a print, so game is created at the end, so we know when it's created, and down here we don't need to do anything because all the elements will be already called to move autonomously and to be drawn in the screen. The enemies are working from different types, as we can see, and also they are respawning when they go at the left of the screen. Moreover, if we wait, eventually also the boosters will come, like the vaccine and the mask. With the code we built, we can create the bullet in a similar simple way. As before, we import the cell class from the cell file and we extend with bullet this class. Now, since the bullet has two states possible, fired or ready, we can create a new class that will be an extension of enum. So we will import the enum class and we will give fired as 1 and ready as 2. So now we can use status.fired or status.ready to define if it's fired or ready. Let's go ahead and let's define the constructor of this new class. As before, the class will have the constructor similar to the cell, but we will add some things. Bullet type, damage, image, and status that we can use status.ready as a default one. Moreover, we call as usual the initializer of the cell class, so we can have initialized also the other fields. We will also add the bullet type variable that we will pass in the constructor, the damage. Moreover, we add the status, so we know the status of the bullet, and we will override the reset function. This reset function will call the reset of the cell and will add the status as status ready, so the bullet, when it's reset, it goes back to ready. And now we can also create the move autonomously function. We will define this function as if the bullet is fired, the move autonomously will move it to the right, so the new position will be the position plus the speed. If it's out of the screen, we will reset it, so if the position is more than pygame display.get window size, so we will also import pygame up here, we will do the reset as usual. When we fire the bullet, we will fire it in a position X and Y. We will get the status and we will set it to fired, we will get the position and we will set it to position X and Y that we passed. So the bullet will be fired and that will be the position of the starting. And for every frame, we'll move autonomously since it's fired and we'll move autonomously to the right. And when it's out of the screen, we'll go back to reset, and when it will be reset, we'll be ready again. Let's define also a function that will help us to ask if it's ready and will return if the status is ready. Let's now create the class normal bullet that will extend the bullet class we just defined, and we will create the constructor. So in the init, the normal bullet will have a damage that we set as default 20. We'll always start ready. We give a name and we give some height, width, and speed. Moreover, we call, of course, the constructor of the class above, so we will call the constructor of bullet that will finish to do the rest. We create also a class rocket that will extend the bullet, and the constructor of this class will have damage, more, as defined in the default status, the name rocket, and of course a different speed. And now we will finish it calling as usual the constructor of the bullet class above. Now, in the code of the main game, we import all the classes that we created for the bullets, and as before, we create some macro so we can see clearly the bullet size up here, the rocket size also here, the bullet speed, and the bullet number. We proceed to create the bullets. Below the player, we create a group, bullets and rockets. We create a rocket, we give the image, and we put as position a position that we calculated to be up right on the screen, so we can see when it's ready. We give all the previous macros, and then we add the rocket to the bullets and rocket group and to the game elements group. Moreover, we create another group only for the bullets. Then we proceed to create as many bullets as the number we define above. We create a bullet for every cycle in this for. We give the image of the bullet, of course also the position of the ready status, and then we pass all the other options that we define above for the creation. We add the bullet to the bullets group, the bullets and rockets group, and to the main game elements group. Once the bullets are created, we go in the main game loop. So every frame we get the event if the player presses a key. So in this case, a key down indicates the moment where the keyboard is pressed. We get the position of the player that we will use later to shoot the bullet. If the key is B, in this case we decided for the B, or the space bar, we can say for every bullet in the bullet group, check if the bullet is ready, And if one bullet is ready, you can fire it to the player position. And we calculate a little bit of offset so it's not gonna intersect the player when it starts. Then we break the for loop here with this break, and the first bullet that is fired will break the for. So first fired will break the event. Then we check if the key pressed is a V. Instead, we can check if the rocket is ready. And if the rocket, in this case only one rocket, is ready, we can also shoot it, giving the player position that we got before. The difference between this event key down and the key get pressed is that the event key down will be true only in the moment when the player presses the keyboard. Moreover, this will be true every time the player keeps the keyboard pressed. So every frame, if the keyboard is pressed on the right, it will go on the right, but only once if the key will be B, it will shoot. We don't need to move the bullets or the rockets because being part of the group will move autonomously, and we don't need to draw them because we'll be part of the group will draw autonomously. Executing the game, we can see that all the bullets are up in the right part of the screen and we have them ready available. If we press B, we can see the bullet is moving, and when it goes beyond the screen, it resets and is back available. If we press V for the rocket, we see the rocket is bigger and slower and gets ready only when it goes beyond the screen again. And now we can shoot it again. The code at this stage will be available as checkpoint 2. You may have noticed that nothing happens when you pick some power-ups. This is because we still didn't implement the collisions, and there are only floating images around the screen without checking if collide into each other. To handle the collision, we will do it in the simplest way, having a rectangle around every entity of the game and checking if it intersects with each other. The right place to do this is in the cell file, because this edit will involve all the cells of the game. Let's get the rectangle from the cell surface image. This method will create a rectangle that is a new type of variable that will be assigned to rect. It has to be called rect since the implementation of the sprite class in the Pygame. After that, we will update the rectangle to the position of the cell when it's created. We define a function update rect that will update the rect position depending on the position of the cell image. Furthermore, since we will start with the power-ups, we will create some new functions that will lose or increase the health of the cell. The function lose health will decrease the health of the cell of the amount lost passed to the function. Moreover, if the cell is not alive, we will kill it with a function that we will define later. If the reset@that argument is true, we will reset the cell, otherwise we won't. At the end, we will return if the cell is alive or not. We will create again the gain health function that will instead increment the health of the amount we define in the game argument. If the health is greater than 100, we will cap the health to 100. Let's also define the functions that we used before, like kill, that will just set the health to 0 and we know the cell is killed, and also is alive, that will tell us if the health is greater than 0. Now that for every cell we have an invisible rectangle that follows it for the collisions, and we also created some game health and lose health for the power-ups, we want also to have some protection time for the player. This is proper to the player, so we won't write it to the cell. Indeed, this is a hint that we have to create a player class that extends the cell class with some extra functions. Let's create the file of the player and we will call it white blood cell. As we know already, we import Pygame because we will use it later. We import the cell also because we will extend it with the player, time because we will need the time for the protection time, and also operating system. From resource path, we will import the resource path function to load the image because we will load the bubble that protects the cell, and we will create now the white blood cell class that extends the cell class. The constructor, of course, as before, we give a name white blood cell and health starting at 100. After the constructor, we call the previous constructor of the cell class to initialize all the variables of the cell class. And also we have the score that we will edit, so every player has a score. This will be useful for a 2-player game, and also is not part of any enemy or power-up, so it's proper to the player. We also create the variable protected till that defines the moment till which the player is protected, and we load the bubble image from the resource path folder. This bubble image will be scaled, indeed as we do for every image, to the right size. We define the move autonomously function and we will just write pass because the player just moves with the arrows. Moreover, now we can define the set protected seconds, so we can say, okay, now the player is protected for some seconds. In this case, protected till will be the moment till the player is protected, and it's now plus the seconds we want to protect the player to. We define also a function that tells us if in this moment the player is protected, and will just return if the current moment is before the moment till the player will be protected. We also add gain score as a function that will increment the score of the player of the score gain argument that we pass to the function. We will return the score indeed, and we will define the reset function, because for this cell we have also to put the score to 0 when we reset the player, and then we call the reset of the normal cell. For the lose health function, we will override the lose health of the cell, and we will set reset at death to false, because the player doesn't have to be reset when it's dying. For this reason, if the player is not protected, we can proceed to call the lose health function of the cell, and we will pass reset at death, that is currently to false. Lastly, we have also to override the function of the cell draw, because we will draw, in the case of the protected part, also the bubble surface image that we loaded before. In the game code file, we can now import our white blood cell that we just created, and then instead of the player as a normal cell, we want the player to be a white blood cell. Since the constructor is the same, there is no problem switching the class. For the collision detection, after moving every game element, we want to update the corresponding rectangle for the collisions. Now we can check, thanks to sprite collide any, if the player collides with any of the power-up group. The result will give us the power-up that is collided by the player. If it's present a collision with this power-up, we will print and will make the player gain some health corresponding to the power-up health increase. Moreover, we will set the protection of the player also corresponding to the collision protected time of the power-up that we collided. Lastly, we will reset that power-up and we will send it back to the previous position. As a last thing, we want to check the player of the health, and if the player is not alive anymore, we want to print player dead and we reset the player. Now, when we collide with a power-up, the bubble will be displayed and the cell will be protected for a certain amount of time. Let's now display the health of the player so we can see if the power-up is working. Inside the white blood cell class, we can go in the draw method, so when the draw is called for the player to draw itself, we will start getting the window size with PyGameDisplay get window size. The first point of the bar, that will be x1 in the middle of the window and epsilon1 15 pixels, and the last point will be x2, the window divided by 6, and y2 15 pixels. We will draw the background black line, and then we will draw the green line that will start from left and will end up at the maximum if the health is full, or at a percentage if there is less health. We create also the font to write the health percentage. We will get the system font with Pygame font, and we will have a health surface with rendering the writing with the color white. At the end, we draw on the screen the health surface text at the position health x2 plus 30 and 10 as y. To initialize the font inside the main game code, we write inside the constructor of the game in the init part pygame.init. When we play the game, now we can see the health is 100% and we can see the bar at the top. Let's now go to the collisions between the enemy and the player. So inside the main game code, inside the game running, for every frame before checking the collision of the player versus the power-up, after updating the rectangle, we can see if we can check the collision of the player versus the enemies. Of course, we have also sprite collide any, so we will check the player and all the enemies. If an enemy is collided, we can say, okay, let's print the health loss and the collision, and then we will make the player lose some health. We call the function of the player, and we will make the health loss as big as the damage of the collided enemy. Moreover, we can make the player gain the score, since the enemy will be defeated, and the score gain will be the health of the enemy. At the end, we will reset the enemy after these frames to move it at the starting point. Now we can clearly see that the player colliding with an enemy will lose health, and having the power-up will increase it back. Meanwhile, colliding the enemies with the power-up will not affect the health. Now, since we created a way for the player to lose health colliding with the enemies and also eventually to die, we have to create the function that we called for resetting the game. The function will display a final score and will reset all the game. First, we create some fonts because we need the font to display the score, and a normal font of size 24 and a big font of size 64 will be created here at the initialize of the game. Meanwhile, we define a new function below the run, between the closing and the run, that will be reset. The reset function that we called here will be in charge of creating the final view with the game over screen and the score and resetting all the elements. First, we create the game over surface with the red text with game over in it, and we create the game over rectangle in the middle of the screen. Below that, we create the score surface with the score of the player written in white, and we create the game over rectangle in the middle of the screen as well. After that, we create a fade out surface in black that we will increment to make a fade out to black. For 90 times, we create a delay, and between the frames we will print the game over surface and the score surface on the screen, and moreover we will make the fade out having a transparency of the variable that we have here. At the end, we will print the fade out, update the display, and print reset for the console. Lastly, we need for every element in the game to call element reset to bring it at the initial position. When we test the game and we eventually lose, the game over screen appears. Another collisions that we want to detect is finally the bullet versus the enemies. So we can create at the beginning the collisions versus the bullet and the enemies with group collide. This will return a list of all the collisions between the two groups. In this case, we will have a list of every bullet that collided with something and the list of collision that this bullet has. So for every bullet that collided, we will cycle it, and every enemy collided with the current bullet, we will say there is a hit, and we make the enemy lose that amount of health as much as the bullet damage does. It can be the rocket, can be the normal bullet. The player will gain the score of the bullet damage that will be equivalent of the lose health of the enemy, and we will reset the bullet to the previous initial position, so it will be back available. Moreover, to visualize the damage that the bullet does on the enemy and its health, we can overwrite the draw function of the cell and call the draw function of the cell, and then add a draw line in green with some transparency of 50% in this case above the position of the cell of the virus. Now we can see the green line of the health of every enemy, and if we shoot at them, we can see that it disappears or it decreases of the amount of damage that we are making them. Last collision that will be funny to implement is the collisions between the bullets and the power-up. Also here we will use the group collide function provided by game that will give us a list of bullets that will collide with something, and for every bullet in the list we will have another list of power-ups that this bullet will be collided with. In this case, if there is a collision, we will decrease the health of the power-up, because it's a cell, so also has a health, of the amount of damage that the bullet does. Moreover, we will make the bullet reset as usual when it collides with something. This will be enough to implement the mechanics of shooting the power-ups and being able to destroy them also by mistake. Let's now come to the final adjustment. First, let's put an icon, because it's still missing, so we will, in the game code, after the caption, also set an icon with pygame image loads, the resource path, and the icon we want. Of course, resource path will be imported up here from the file we defined before. Moreover, after the icon, we will put icon transform and we'll scale it 64 by 64 as a normal icon, and we will set icon as a function of pygame display, set the one we just created. Now we see the icon of the game that is like our player. Another adjustment can be drawing the score, so in the game for every frame we can draw the score after drawing the screen and before drawing all the elements. So we create the score surface, we render the score text with the player score that we get in white, and then we will write the score surface on the screen with self screen blit and the score surface. Now we can see that the score updates in real time and we can see as many points as we are making. Another important thing to add to the game is the music, otherwise it won't be complete. We can initialize the modules and initialize the music with Pygame Mixer and pass the frequency that we want. Moreover, if the mixer is successfully initialized, we can load the music path. In this case, I have a background music in WAV that it will repeat itself, and load it as a resource path in the Pygame Mixer and also make it play, and -1 is repeat on repeat. Last thing that we have to do is when we reset the game, when the player is dying, add, if the Pygame Mixer is active, a fade out, so the music will slow down and fade out, and then after showing the game over screen, when we will be resetting all the elements, remember also to reset the music and set it also to play on repeat. You can use this code also to create music and sounds for every event of the game, like collisions and special events. Let's now create the background file with the background code. As usual, we import in the file Pygame and the operating system to load the images. Then from resource path we import the resource path function and we create the class background. In the class background we create the constructor that will take in input the image, the width, the height and the speed in which the background will move. The normal background will be static, so the speed will be 0. Then we save the width, height and speed as local variables in the initializing. We create a surface because we need to load the image from the resource path inside the image folder, and we scale the desired surface to the width and height we got in input. Moreover, we save the rectangle that the surface has. When we need to move the background, we get the rectangle and we get that to move at the speed selected before. If the position is out of the screen, we will put it back to 0. This means that if the top left part of the image, the corner on the top left, will go beyond the width of the image on the left, the full image will be not visible anymore on the left, and we can spawn it back in the center of the screen and start from 0 and go back to the left. If we need to draw it, of course, we will draw the surface on the rectangle, and in the scrolling background class that we will create extending the background, we will set the default speed to 1 in the constructor, and we will call the constructor of the class superior, so the background constructor. Moreover, when we draw the scrolling background, we need to draw the surface itself on the screen and the rectangle, and to draw a copy of the self surface that's moving at the same speed on the right. So the surface will start from the top right part and will scroll on this way till the center, and the other surface will start from here and will scroll on the left, so they will be seamlessly interchanging. In the game we will just import the class we just created, in this case the scrolling background, we will use just that, and after the fonts in initialization of the game we will create the background. We will create a scrolling one with an image that we get from the image folder and the width and the height of the screen. Moreover, we will set a new background also with particles that is transparent, and we have a PNG with transparent background with width and height of the screen. In this case, we will give a speed that is double than the normal scrolling speed. When we draw the elements on the screen, we can also draw, after filling the screen of black, the background. We will draw the background normal, and we will move it firstly of one step of pixels, and then we will draw it on the screen. The second background with the particles will be over it, so we will move it and then eventually draw it also on the screen, before drawing all the other surfaces like the score and the game elements on the top. Now, if you play the game, you can see the background is scrolling and also the particles in front of it. Now the game is complete. I hope you enjoyed the tutorial and you learned something. You can feel free to extend it, adding sounds for other types of events, adding maybe the enemies that can shoot as well, make the difficulty faster with the time, or even add 2 players in the same keyboard to challenge a friend. The code and the link to my GitHub is available in the description below. Thank you for watching.